we saw this matrix in a previous video where we're asked to find the eigenvalues, and the question did not ask us to find the eigenvectors, but let us find the eigenvectors. Remember, in the working we did in that video, the eigenvalues were lambda 1 equals 1 and lambda 2 equals 3. No, it was negative 3, not 3. It was negative 3. Now, if you remember how to work it out, you can pause the video, go ahead, and find the eigenvectors. If not, I would recommend that you look it up, whether in a previous video or notes. You look up how to find the eigenvectors and work it out. So go ahead. Okay, you've done it. What did you get for the eigenvectors? Okay, I'm going to look at it. Let us look at finding the eigenvectors. Now, here, you would have seen in the previous work that you had AX equals lambda x. So the vector, the matrix A times its eigenvector x is equal to the eigenvalue of the matrix lambda times its eigenvector x. Alright? So AX minus lambda x equals 0. Now, lambda is supposed to be multiplied by I. It's lambda I, because lambda is a scalar, it's just a number. And in the case where you have AX minus lambda x, x here, if you factor out x, you get A minus lambda if you don't have the I there. But you cannot have a matrix, for a 2 by 2 matrix A minus a number. So you must multiply by I. Alright? Now, in this case, you would have looked at the fact that, let me put x on the right. X is a 2 by 1, it's a column matrix. Let's move all of these things to the right to make space, and x would come here. Right, it's a column matrix. So if you have a 2 by 2 matrix A, B, C, D, you can have a column matrix on the left, call it EF. Right? E times A plus what times B is row times column. So you put EF on the right. So you have EF. So A by E plus B times F. So that's why I put X on the right. Now, here, A is the matrix 2, negative 5, 1, negative 4. There is 2, negative 5, 1, negative 4 minus lambda I, which is 1, 0, 0, 1, and all of this times x is equal to 0. Now rewrite them in their matrix form. You're going to have 2, negative 5, 1, negative 4 minus lambda 1, 0, 0, 1 times x. Now X is a column matrix. Let's call it X1, X2 equals 0, 0, 0, written as a column matrix too, not a number. Now, here, if you multiply lambda by what is in the bracket, you're going to get lambda 0, 0, lambda. You see that? So, might as well just do it from now. It's lambda 0, 0, lambda. Okay? Now, the thing is, when you consider that there are two lambdas, when lambda equal 1, using lambda 1 equal 1, one of the first eigenvalue that we found, lambda 1 is 1. So in this case, we have 2, -5, 1, -4, minus this is going to be 1, 0, 0, 1 times the eigenvector, whatever it's going to become, x1, x2 is equal to 0, 0. And you're going to work that out, alright? So here we're going to have this minus this. Remember, you're subtracting two matrices here. Element in row 1, column 1 minus element in row 1, column 1. Yeah. In row 2, column 2 minus row 2, column 2. Row 1, column 2, I should say. Then this is row 2, column 1 minus row 2, column 1. Row 2, column 2 minus row 2, column 2. You subtract the corresponding elements. Alright? So, you have 2 minus 1. I'm just looking at all the steps here. -5 minus 0. 1 minus 0. -4 minus 1. Right? Times x1, x2 equals 0, 0. Okay? See that? Remember, we're not rushing through it as if we're in exam and I want you to fully understand what you're doing and the reason why you do what you do when you work it out. So 2 minus 1 is 1. -5 minus 0 is just -5. 1 minus 0 is 1. -4 minus 5 is -5. x1, x2 equals 0, 0. Now let's look at this matrix here. You must either have the columns having the same thing, column 1 having same numbers, column 2 have the same number, right? Or the same row. Alright? Now, here, if you should multiply these, you're going to have 1 by x1, that's x1, plus -5 by x2, -5 x2 equal 0. This equal tail here kind of long. If you multiply row 2 by the column matrix, you get the same thing. 1 by x1 is x1 plus -5 by x2 equals 0. Same thing. So I won't bother to do this part. So here, if you add 5x2 to both sides, you get x1 is equal to 5x2. So, what you're going to have for the eigenvector is in the form x1, x2. But in this case now, you say x1 is equal to 5x2. Now don't make the mistake of writing x1, for example, as a 1 and x2 as a 5. Because x1 is 5 times x2. If you have x2, you have to multiply it by 5 to get x1. And if you multiply 5 by 5, you won't get 1. So what you do is say x2 is 1. So, and remember, you don't have any specific value for x1 and x2. There can be any value as long as the sizes correspond, the ratios. So when x2 is equal to 1, x1 is equal to 5 by 1, which is 5. So x2 is 1, x1 is 5. You could even say x2 is 2, you know. It's the same thing as saying x2 is 2, x1 is 10. Right? It's just that you can factor out 5 and get back 5, 1. So this is an eigenvector. This is also an eigenvector. Right? But use the smallest numbers available. So for the eigenvector is this, corresponding to lambda 1 equals 1. Right? Was it 1? Yeah. The first eigenvalue was 1. This is the eigenvector. Alright. We want to see what happens when we use lambda 2 equal negative 3. So let me see something. Let's draw a line and work on the right. Alright? Instead of working down. Because we soon run out of scrolling space. We can't scroll down anymore any further. So let's just use this. Alright, so this was when we use lambda 1 as 1. Let's use lambda 2 equal negative 3. So we want to find out what is the eigenvector when the eigenvalue is negative 3. So again, we see we have 2 negative 5, 1 negative 4. We have 2 negative 5, 1 negative 4 minus lambda 0, 0, lambda, but in this case lambda is negative 3, so it's negative 3, 0, 0, negative 3 multiplied by x1, x2 equal 0, 0. We have this as x1, x2. Maybe I should change the name because I have x1, x2 and I wrote x1, x2 already. So let's call them x3 and x4. Alright? x3, x4. Okay? Alright. So here now, subtract, so 2 minus, by the way, we don't want to have too many minuses to cause confusion. So let's rewrite this, and we're going to factor out the negative. So you have 2 negative 5, 1 negative 4. If we say minus negative, we have a 3, 0, 0, 3. But the minus negative will be plus. So we say plus. Right? x3, x4 equals 0, 0. Alright? Now, it's a bit easier to work with this, and you're less likely to get your brain mixed up and make mistakes if you just work with this instead of saying minus negative, right? Especially if you're under exam pressure. All right, so you have 2 plus 3, negative 5 plus 0, 1 plus 0, negative 4 plus 3. See that? X3, x4 equals 0, 0. All right. So 2 plus 3. You have in this case, you're going to have 5. Negative 5 plus 0 is negative 5. Let me see something here. So you have negative 5, negative 4 plus 3, 5 negative 5, and then you have 1 plus 0 is 1, negative 4 plus 3 is what? Negative 1. Oh, they should have the same things lined up, so seems like I made some mistakes somewhere here. Let us see what happened here. Negative oh, they are lined up. Yeah, you have 5 1, but negative 5 negative 1. It's just that this is negative and this is positive, so they are properly lined up. I didn't make a mistake there. All right, so x3 x4 equals 0, 0. So here now, if you should multiply this row by the column matrix, you would have 5 by x3 minus 5x4 equals 0. If you multiply the bottom, the row 2 by the column matrix, you'd have 1x3 minus x4 equals 0. But notice, this is the same thing as this, It would imply that if you divide both sides by 5, you get x3 minus x4 equals 0. So one is just a multiple of the other, right? So x3 minus x4 equals 0, x3 minus x4 equals 0. One of them is just a multiple of the other. So they should be the same when you work it out like that. So this is saying x3 equals x4. If x3 equals x4, then what you have is that the eigenvector corresponding to lambda 2 equal negative 3 is, alright, x3 and x4 are the same, so you just use 1, 1. Alright? You just use 1, 1. So in summary, what you can say is that when lambda is 1, when lambda equal 1, x equal, so when the eigenvector is, when the eigenvalue is 1, the eigenvector is 5, 1. And when the eigenvalue lambda is negative 3, the eigenvector x is 1, 1. Alright. So we can do a quick summary. So you're finding the eigenvectors. You have two eigenvalues already. Here, you can reason this out again. Easier to remember it this way than trying to swat a shortcut method. So here you're using lambda 1 equal 1. And by the way, if we're using lambda 1 equal 1, I could even relabel this to, and say this is x1a and x1b. So if I say lambda 1, you just say x1. But there will be two x's. One of them is a, one of them is b. I like this labeling. It just came to mind. Right? So x1a and x1b. x1a, x1b. That. So x1a is equal to negative 5 to x1b. So x1a is equal to x1 5x1b. You don't have to do that, It's just that it just came to mind that if I have lambda 1, I could label it as x1. But there are two x1s. Alright, so x1a is 5, x1b is 1. Alright? When you work it out like that, so you put it in this form, subtract the corresponding elements, simplify, multiply the matrices. You should have these lined up. Right? Here the two rows are the same. Over here the two columns are the same. Alright. Well, not really the same. One of them is a positive and one negative. But you should have the same numbers lined up. 5, 1 and 5, 1. And here you have 1, 1 and you have negative 5, negative 5 lined up. Alright? So that when you multiply them, you get a general value for lambda 1a, lambda 1b. I could call this lambda 2a and lambda 2b, right? I just like this labeling, lambda 2a, lambda 2b, but you can label them in an appropriate way that you choose. Alright? Whatever appropriate way you see to label them. So here we get these values. When the eigenvector is 1, when the eigenvalue is 1, the eigenvector is 5, 1. When the eigenvalue is negative 3, the eigenvector is 1, 1. I'm going to ask you to, if you didn't get it correct when you tried it by yourself, I'm going to ask you to try this again without looking back at any notes or looking back at the videos or at this video, alright? Or any other video, right? Label the common practice is to label them lambda 1, lambda 2, and then the x's, you could label them x1 and x2 when you have lambda 1, and then x3, x4 when you have lambda 2, or you could label them as I put here. When you have lambda 1, you find x1a and x1b if you want, right? But the important thing now is that you work it out step by step, show all the steps, and get the correct values. So that's that. I'll see you in the next video.